You went away for a moment. Were you having problems?
What's going to happen when we're on campus? If the good party's out again.
Hey guys. Hopefully everyone is doing well. What are we, Thursday, week 7? So week's just about done here. I can feel the start of school coming. It's closing in quick. Well, school's doing all the preparations. We got like these plexiglass dividers. Apparently I found out you can't use drinking fountains anymore. So they've been working on dealing with that. So a lot of preparation underway here at the school, getting ready for you guys coming back. So hopefully everything will be in place and ready to go for when you arrive. We're scrambling, trying to get everything done, making sure it's all in good shape when you get here. They moved all the tables around out front and everything, so a lot of little changes. A couple of the people here at the school did a fantastic job doing some extra painting too. So there's all these like cat paw tracks all over some of the new, some of the pillars, and they did it to some of the wall walls and everything too. So it's really cool looking. A lot of the people were able to put extra time and get things done we don't normally get done. So it's pretty cool, actually. I think you'll be amazed when you come back and see the campus. It looks really good. We were all working hard while you were gone. Yeah, Mason?
Will there be like, you go to stores and those?
Hey, speak into your mic a little.
So you know how you go to stores and like Walmart, for example, I know they have them, and it says shop this way, do not enter. Oh, it says that. I don't know if you ever go there.
I don't know. The only store I ever go to is the Rayleigh's right by my house, and I hadn't seen those yet.
Well, no, Walmart, I think Target also has it, but I don't know. It's like keep people away from each other and keep them all walking one way. Will we have to do that at school when we go back?
Have one way. That's interesting. So that was not at my store. I hadn't noticed that, but I have seen that before where they do make you walk in a certain path. I haven't seen that happening here at the school, so I don't think so, but maybe. I don't know.
I would actually like that, not because of coronavirus or anything, but I would just like it so it's more easier to walk
the
and not
mass
have
of
to
people.
shove through everyone.
Yeah, I know. It's a mess. Wait till you get to high school. It's even worse. All right, guys. So anyways, today's kind of an exciting day because you are at the point where you've got enough electrical knowledge to where things are starting to make sense. And the stuff we're covering today, I think once we're done with today's stuff, you'll have a decent understanding of how an electrical circuit works. So it's kind of a cool time. Electricity is one of those subjects where it takes a lot of little pieces to kind of get all these little bits of knowledge, and then all of a sudden, bang, they all click together and they start working. And so today, I think, is that day. So if you're a little behind and it's still not clear to you, don't worry. We'll still have lots of practice and it will become clear. But today we'll make a lot of this stuff clear for a lot of you guys. So let me pull up my presentation here. Share screen. Okay, now where are the notes? Is that them? No, that's not them. Sorry, all my notes always move around here. Let's see here. Circuits. There we go. Okay, so just a quick little review here. Oops, come on. There we go. That's interesting. Somehow I turned my presentation blue. Always gotta be something. I would like to get rid of the blue there. Oh, geez. All right. So anyways, we did some electrical symbols yesterday. Remember, battery has a longer line and a shorter line, and the longer line is the positive and the shorter line is the negative. And the amount of those paired together tells you how many cells are in a battery. Okay, that'll be very important when we start doing some of the diagnostics for electrical circuits. Okay, we also figured out the ground. Ground is just going to be the symbol for the path back to negative. So if you look on this battery here, do you see where the plus is? If I just ran a wire out, I could run a wire to the negative, and that would be a complete circuit. Or I could run this wire out to a ground symbol, and this wire out to a ground symbol, and that would be a complete circuit too. So a ground is kind of a alternative for the negative side of the electrical circuit. So what I always like to tell people is, if you look at a car from the 90s, what you'll notice is the car has 7 miles of wire in it, okay? 7 miles of wire, and that's a car from the 90s. I don't know what it is for today. It's probably, you know, twice that, because everything's so electrical now. But that being said, cars use something called a ground. And what that means is they can eliminate the negative wire from most of the circuits, or at least vastly shorten it, okay? So just think about that. A car that has 7 miles of wire would actually probably have about 12 miles of wire in it if we couldn't use grounds. So that's what the ground symbol is. We'll use it a whole bunch later on, and you'll see what it is. I wish we were here in class, because I have demonstrations to show you how all these things work, but here over the computer, I just can't do it. So unfortunately, we'll just have to sit back for a little bit, but we'll get there, okay? Now, we do have some other circuits or other symbols that I want you to know. And see these 3 right here: circuit breaker, diode, and fuse. These, I would like you to write down all 3 of those, and then I'm going to tell you a quick definition of them, okay? So just put down circuit breaker, diode, and fuse, okay? Okay, so the definition for a circuit breaker, well, actually, let's start with fuse first. Fuse will make it easier. So the definition for fuse is a sacrificial piece of equipment that will protect the rest of the circuit. So in other words, fuses are cheap. I should have grabbed some. I got them over in the electrical room. But the fuses are really cheap. They're usually just 10 cents, $1, $2, $5. They're cheap, okay? And fuses are there to protect the rest of the circuit. So you guys have your Xbox, probably has a fuse in it. Your car radio has a fuse in it. Everything actually in your car has a fuse in it. Your house wiring has, well, circuit breakers in it, but they have fuses in it. And the fuse is there, it sacrifices its life and then kills the circuit. So if too much electricity is flowing through, the fuse will burn up and protect the rest of the circuit. So it gives its life for the rest of the circuit, okay? It's a very noble hero in that sense. It protects expensive equipment by killing itself, okay? So that's the fuse. And you see on the picture of the fuse how it has this little like curved line. So if you look at a fuse, it usually has 2 ends and then a wire stretched between it. And it's usually not a curved wire, it's usually just a straight wire. And that wire will burn, and then all of a sudden you'll see a little split in the wire, and that tells you that the fuse is bad, that it's been burned up, that it's already given its life. You can bury it as a hero. Okay, so that's a fuse. Hey guys, speak up too, because I can't, if you have a question, because I can't see everyone. Yeah, Samar's got one right there. Perfect. Is that one good or bad? I can't tell from the video.
This one's good.
Good? Okay, yeah, Samar's got one there. Yeah, speak up guys, because I can't see everyone's picture. I'm here at my home and I can only see a few of you. Yeah, that's awesome. That's perfect. And we'll learn how to test those with the multimeter, because sometimes you can't always tell when they burn up. Usually you can. They're made so that you can, but they don't always work that way. Okay, so that's a fuse, right? It's a one-time use. As soon as it's dead, it's done, okay? So make sure you have that under your definition for fuse. It gives up its life to protect the circuit, and 2, once it's burned up, it's dead. It cannot come back to life, okay? All right, now let's move to the circuit breaker. The circuit breaker is a similar type of device. It's there to protect the circuit. We have these in our house. In fact, let me just go grab one real quick. I'll show it on camera.
Mr. In the energized, never mind.
Okay. I think somebody was saying something, maybe Suleiman, but I walked away, so I didn't hear it. What was it?
Yeah, it was me. In the de-energized relay circuit, what's that squiggly thing next to the resistor?
That's very cool. I'm going to talk about that in a second. So that's a really cool circuit, and it's kind of your first little taste of a circuit. So I'll get there in 1 second. It's cool, I promise. Okay, so this is a circuit breaker right here. Okay, and I don't know if it shows through on there, but it's a 15 amp. You can see the 15 on there. I think it shows through. Okay, so that's a 15 amp circuit breaker. Very typical for a lighting circuit in your house to be 15 amps like that. Okay, what this circuit breaker does is if too much amperage is flowing through the lines, more than 15 amps, this thing will shut off. And you hear that click? It will shut off like this and turn off the power. But the nice thing with circuit breakers is they're resettable. I can just flip the switch and it goes right back on. So that can be good and bad, because if I turn it back on and the circuit still has whatever problems in it, it might just blow again or could cause something to burn up. Usually this will just throw. So it's on, it gets thrown, I come over and turn it back on. If there's still a problem, then it'll just throw itself again, usually, okay? Sometimes it doesn't, but usually it will just throw itself again, and then you realize, okay, there's something more serious, I gotta go fix the problem. Sometimes it's just because you have the microwave, the hair dryer, and the dishwasher going at one time, and it's just too much electricity and it throws the circuit. So you stop one and flip the breaker, and then it's working fine again, okay? Mason, you had a question?
Yeah, pretty sure that happened to my dad one time, and I remember I went out there and he showed me how to reset it.
Yep, it's very common. All of you guys should know how to reset them. We will all do that in the class. That's one of your tests, is for you to reset these. So I don't know if it shows on camera, but I'll try to get it to. So right now it's in the on position. Let me make sure. Yep, it's in the on position. Okay, and now if it gets thrown, what happens is it sits in this kind of, oops, it sits in this kind of middle position like that. Okay. It sits in the middle position if it's thrown. So you'll be able to tell, because all of the breakers will be in one position, and then you'll see one that's sitting in the middle like that. So you have to look close, because it's hard to see it unless you're looking for it. Like your parents that don't know anything about electricity, they'll probably miss it. But as long as you know what you're looking for, you'll find it easily, okay? So it'll sit in the middle like that. And then, so it's on, it gets thrown, and it will sit in the middle. And then what you have to do is turn it all the way off and then all the way back on. And then it's ready to go again. Okay, so it's very, very simple device. You'll do this in class. I'll have all of you do it. Okay, so now let's go to these switches over here on the left side, and then we'll talk about that relay, because the relay is the most complicated. Okay, so if you look at these two switches here, there's a normally open switch and a normally closed switch. Okay, and there's two types, and the way you can tell is follow the electricity. So electricity will come in on this left side here, and it will get stuck, right? It can't jump across because there's this open space right here. Okay, so it gets stuck. So that's a normally open switch, meaning that the circuit is open, and when it's open, no electricity will flow. Okay, this will be like the ones in your house where you go and you flip them. Actually, your house isn't a good example for this. What would be a good example? Your Xbox controller is a normally open switch. So it sits open, and then you hit your A button, and all of a sudden your gun fires or your character jumps or whatever it is, okay? That's a normally open switch. So it's not allowing electricity to flow except when you hit the button, okay? That's a normally open switch. So that's probably a good example of that. So once you hit the button, you actually are depressing this little line here, and it will touch the other contact and allow electricity to flow. So that's a normally open switch. Here's the opposite. This would be a normally closed switch over here. So this switch allows electricity to flow through all the time until I go ahead and throw the switch. Okay, once I throw the switch, then it opens the circuit and no electricity will flow through it. Okay, so we use these on things like our hazard lights in our car. You know, when you turn those emergency blinkers on, well, the lights are on all the time until that little relay opens up the circuit, and then it doesn't connect anymore. So we use both of these circuits a lot. They both do different things, okay? And actually, once we get into computers, we'll use them all the time when we introduce sensors, okay? So those are the two types of switches. So just remember, open means the circuit's open and not allowing electricity to pass. Closed means the circuit's closed and electricity can flow through. And it's easy to tell by the picture because you can tell the normally closed will be touching, okay? All right, now let's get to the coolest one on this page right here, and that is this de-energized relay. And the reason it's de-energized is because there's no power flowing through it yet. So there's two circuits in this energized relay, and relays are a fantastic device. They use an electromagnet in them, and what they do is they allow us to use very low voltages to control very high voltages or very, very high amperages, okay? So typically, so look at the cord for your mouse, or if maybe you have a cordless mouse, but look at the cord for your mouse. It's very skinny, right? Well, the cords that you see on the telephone poles, they're fatter than your garden hose. Okay, they're big, fat, thick wires. And they have to be because they need to pass that much electricity. But obviously, we can't use those big, fat wires everywhere, right? You wouldn't want to have your mouse cord be one of those big, fat wires. You want it to be the smallest wire possible. So they've developed these things called relays, and they use electromagnets to allow low amperages or low voltages to control high amperages and high voltage, okay? So let's just pretend this is our car right here, okay? We're gonna pretend it's our car. Cars have big batteries in them, and one of the things that takes the most electricity is the starter. The starter can take anywhere from 80 to 120 amps, okay? Just to put that into perspective, your house, your whole house, some houses only go up to 100 amps, okay? The big houses go up to about 200 amps, and then the huge mansions that you see around sometimes have 400 amps. But if you lived in the house in the 80s or 90s, your house probably has 100 amps. And if you lived in a house that was built in the 2000s, it's probably starting to be in the 200 amps because we started to use more electricity. Okay, so just to put that into perspective, a car is using 80 to 120 amps just for the starter, okay? Similar to your whole house amperage use. Okay, so now let's just pretend where I've got my cursor up here is the battery, and let's just pretend on the other side here is the starter. We'll actually make this fuse be the starter, okay? So we need a very high amperage big wire to run all the way from our battery to our starter, right? All the way from our battery to our starter. But we don't want the wire that runs to our key, that tiny little wire that's in our steering column. We don't want that wire to be huge. If it was as big as a battery wire, we'd never be able to fit all those wires in our car, and the cars would probably be twice as expensive. Okay, so just imagine we've got your battery up here. It's going to run through here, and it's going to end up in the starter motor. Okay, can we kind of picture that so far? So we've got positive electricity running down this wire, comes down this direction. Oh, I'm sorry. And yeah, it does not go to the starter yet. So right now it's just running through, okay? So it's going down, battery, it's coming down here over to this 87A, and it's just being stuck out here. It's not connected to anything yet. And then we're gonna connect this 87 to our motor over here, okay? This 87. So what happens is when this little arrow swings over to 87, now we have a straight line from our motor from our battery all the way down to our motor, okay? Battery all the way to the motor, okay? And then, sorry, I wouldn't be going through this in quite so much detail, but Suleiman asked, okay? So battery all the way down to the motor, but we have to swing this arrow over, okay? Now this is a huge fat wire here, and this wire over here is from our key in our car, and what this is an electromagnet. So when you turn the key on, what it does is, this is a resistor right here, And this is something called a coil. It's a magnetic coil. And when you charge it, it makes this magnetic coil turn magnetic, okay? And the magnet here attracts this arrow over and then allows the electricity to flow. So, God, I wish I could draw this on the board. It's so much
Is that
easier
an
if I could
inductor?
point.
Is that an inductor, Mr. A? Is
Yeah, go ahead.
that an inductor?
It is, yeah.
Okay.
Well, it's using inductance to pull it over,
I'm,
yeah.
I'm talking about the thing that the resistor is next to.
Yeah, that's an electromagnet.
But wouldn't we wind up inducing current on the switch itself?
You do. So electromagnets can do one of two things. So you can either make electricity using a magnet, or you can use electricity to make something magnetic. So it can go either way. And we'll find that a lot in electricity. You can go one way or the other. Same thing with motors. You can turn a motor to make electricity, or you can use electricity to turn a motor. And the same thing with an electromagnet. Yeah, so you're inducing a magnetic coil to energize, and you're using electricity to do it. And that's what it's showing right there.
Why the resistor, though?
That's just showing a load. It's just showing electricity being used. A resistor
So
is
it's not,
yeah, it's just
is it
showing.
an actual resistor, or is it just?
No, it's sending electricity through a coil of wire.
Okay.
We'll actually cover these in better detail later. I just throw it up here just to show you one, but I don't really cover it right now. But we actually use these later on. They're really common. They're very common in electronics. The main thing to remember is it allows low voltage to control high voltage, or low amperage to control high amperage.
Are we going to cover diodes?
Yes. Oh, shoot, I forgot. Yeah, I got talking and then I forgot about diode. Yes, diodes are super important. And when we talked about conventional and electron theory, remember it only going one way. So diodes are going to be used with conventional theory, but well, let me just show. A diode is this. Again, I apologize. I hate not having this in person. It's so much easier when I have my models in front of me. So electricity can only flow the direction that the arrow's pointing. Okay? It can only flow the direction the arrow's pointing. So if you ever see this symbol, that's a diode. It's a one-way check valve. Okay, so for the definition of diode, it's a one-way check valve. Only allows electricity to flow one way. So if electricity came from this side over here, it would hit the diode and be stopped. It would not be able to go through the diode. We're going to use those later on to turn alternating current into direct current. We also use them a lot with computers. And then you guys probably know, you've heard of LEDs, which is light emitting diode. Those are also diodes as well too. So we'll use those a lot when we do the robots, and you'll learn all about them. But diode is a one-way check valve, allows electricity to flow one way, but not the other. Okay, sorry, we went a little bit slower than I was anticipating. I was thinking we were getting into circuits today, but that's okay. We'll do circuits tomorrow. Circuits are where we really start to get in and see how the electricity moves. So let me see, I think it's 9:37. Yeah, I better kill it there for today in case anyone needs anything graded or help with anything. So I'm gonna kill the lecture there today. If anyone needs